According to the National Electrical Code, the white conductor of Romex cable is not allowed to be re-identified as another color, even when it is enclosed in EMT. This is because a white conductor is the ground neutral, otherwise known as the grounded conductor. Re-identifying the white conductor could lead to confusion and create potential safety hazards, such as misidentification of the ground path. Sleeving Romex in EMT is generally permitted, but only under specific conditions. Firstly, the EMT must be properly installed and grounded. Secondly, the Romex should not be exposed to excessive heat or stress. Thirdly, the from-to method is used, indicating that the Romex is sleeved continuously from one junction box to another. This approach ensures the conductors are protected and helps prevent short circuits. When dealing with three-phase equipment, it is recommended to use properly sized and color-coded conductors for each phase instead of attempting to re-identify the white conductor. This ensures accurate phase identification and enhances the reliability of the electrical system. When sleeving Romex in EMT, several guidelines should be followed. Firstly, use EMT with an internal diameter large enough to accommodate the Romex and provide space for any necessary insulation. Secondly, choose an approved sleeving material that is rated for the temperature and voltage requirements of the Romex. Thirdly, ensure the sleeving is tight and secure to prevent movement or damage to the Romex. Finally, avoid making any splices or taps within the EMT. Always consult with the local electrical code and a qualified electrician before performing any electrical work. Understanding these guidelines is crucial for ensuring electrical safety and compliance with regulations. The National Electrical Code sets standards for electrical installations to protect people and property. Adhering to these standards minimizes risks associated with electrical work. The proper grounding of EMT is essential for safety, providing a path for fault currents to return to the source and trip protective devices like circuit breakers. This helps to prevent electrical shocks and fires. When Romex is subjected to excessive heat or stress, its insulation can degrade, potentially leading to short circuits or other electrical problems. Therefore, it is vital to ensure that the installation environment is suitable for Romex. The from-to method of sleeving Romex in EMT offers enhanced protection compared to other methods. By continuously sleeving the cable between junction boxes, the risk of physical damage is reduced. Using properly sized conductors for three-phase equipment is essential for balancing the load and preventing overheating. Color coding helps to identify each phase easily, which is important for maintenance and troubleshooting. The diameter of the EMT must be adequate to prevent overcrowding, which can lead to insulation damage and overheating. The sleeving material should be compatible with Romex and the environment in which it is installed. It should be resistant to moisture, chemicals, and other factors that could cause degradation. Securing the sleeving properly prevents the Romex from rubbing against the EMT, which can wear away the insulation over time. Splices and taps inside EMT are generally prohibited because they can create points of failure and are difficult to inspect and maintain. Consulting with local electrical codes ensures that the installation complies with specific requirements in your area. These codes may vary depending on the location. A qualified electrician has the knowledge and experience to perform electrical work safely and correctly, minimizing the risk of errors and hazards. When working with electricity, it is important to prioritize safety and follow all applicable codes and regulations. This includes wearing appropriate personal protective equipment, such as gloves and safety glasses. It is also essential to de-energize circuits before working on them and to use proper testing equipment to verify that the circuits are indeed energized. In addition to the guidelines mentioned earlier, there are other factors to consider when sleeving Romex in EMT. Firstly, the length of the EMT run should be kept as short as possible to minimize the risk of pulling damage to the Romex. Secondly, the EMT should be securely supported to prevent sagging or movement. Thirdly, the ends of the EMT should be reamed to remove sharp edges that could damage the Romex. When pulling Romex through EMT, it is important to use a lubricant specifically designed for this purpose. This reduces friction and makes it easier to pull the cable without damaging it. It is also important to avoid overbending the Romex, as this can weaken the conductors and insulation. The minimum bending radius for Romex is typically specified by the manufacturer. When connecting EMT to junction boxes, use appropriate fittings that are listed for this purpose. These fittings should provide a secure and watertight connection. If the EMT is exposed to the weather, use weatherproof fittings to prevent moisture from entering the conduit. When installing three-phase equipment, it is important to ensure that the phases are properly balanced. This means that the load on each phase should be approximately equal. Unbalanced loads can lead to overheating and equipment failure. To balance the load, distribute the circuits connected to the three-phase equipment evenly among the three phases. It may be necessary to adjust the wiring to achieve a balanced load. If you are unsure about how to balance the load, consult with a qualified electrician. When working with electrical equipment, it is important to follow the manufacturer's instructions carefully. This includes instructions for installation, operation, and maintenance. Failure to follow the manufacturer's instructions can void the warranty and create safety hazards. It is also important to keep electrical equipment clean and free of debris. Dust, dirt, and other contaminants can accumulate and cause overheating or equipment failure. Regularly inspect electrical equipment for signs of damage or wear. Replace any damaged or worn parts promptly. If you are not qualified to perform electrical work, it is important to hire a qualified electrician. Electrical work can be dangerous, and it is important to take the necessary precautions to protect yourself and others. A qualified electrician has the training and experience to perform electrical work safely and correctly. They can also ensure that the work complies with all applicable codes and regulations. When choosing an electrician, it is important to select someone who is licensed and insured. A licensed electrician has met certain requirements and has passed an examination to demonstrate their knowledge and skills. An insured electrician has insurance to protect you in case of accidents or damage. It is also a good idea to ask for references and to check the electrician's reviews online. When you hire an electrician, be sure to communicate your needs clearly and to ask any questions you may have. The electrician should be able to explain the work that needs to be done and to provide you with a written estimate. Once the work is completed, be sure to inspect it carefully to ensure that it meets your expectations. If you are not satisfied with the work, contact the electrician immediately. In addition to the information provided in this narration, there are many other resources available to help you learn more about electrical work. These resources include books, websites, and training courses. It is important to stay up to date on the latest codes and regulations. The National Electrical Code is updated every 3 years, so it is important to have the latest edition. There are also many online resources that provide information about electrical codes and regulations. These resources can be helpful for understanding the requirements in your area. If you are interested in becoming a qualified electrician, there are many training courses available. These courses can provide you with the knowledge and skills you need to pass the licensing examination. There are also apprenticeship programs that allow you to learn electrical work under the supervision of a qualified electrician. These programs can be a great way to gain practical experience and to prepare for a career in the electrical field. Electrical work is a challenging and rewarding profession. It requires a strong understanding of electrical principles, as well as the ability to work safely and efficiently. If you are interested in a career in the electrical field, there are many opportunities available. With the right training and experience, you can become a qualified electrician and enjoy a successful career. The National Electrical Code, or NEC, is a comprehensive set of standards that governs electrical installations in the United States. It is published by the National Fire Protection Association, or NFPA, and is updated every 3 years. The NEC covers a wide range of topics, including wiring methods, overcurrent protection, grounding, and equipment installation. It is important to follow the NEC when performing electrical work to ensure safety and compliance. The NEC is not a law, but it is often adopted by state and local governments as a basis for their electrical codes. This means that if you violate the NEC, you may be subject to fines or other penalties. Even if the NEC is not adopted as law in your area, it is still a good idea to follow it. The NEC represents the best practices for electrical installations and can help to prevent accidents and injuries. There are many different types of wiring methods that are allowed by the NEC. These include Romex cable, EMT conduit, and individual wires in conduit. The type of wiring method that you choose will depend on the application. For example, Romex cable is often used in residential wiring, while EMT conduit is often used in commercial and industrial wiring. Overcurrent protection is an important part of any electrical system. It is designed to protect the wiring and equipment from damage in the event of a fault. Overcurrent protection devices include circuit breakers and fuses. These devices are designed to trip or blow when the current exceeds a certain level. Grounding is another important aspect of electrical safety. It provides a path for fault currents to return to the source, which helps to prevent electrical shocks. Grounding is typically achieved by connecting the electrical system to a grounding electrode, such as a metal rod driven into the ground. Equipment installation is also covered by the NEC. This includes requirements for the installation of electrical equipment, such as lighting fixtures, appliances, and machinery. The NEC specifies the minimum requirements for the installation of this equipment to ensure safety and proper operation. In addition to the NEC, there are also other standards and regulations that may apply to electrical work. These include state and local electrical codes, as well as standards from organizations such as the Institute of Electrical and Electronics Engineers, or IEE. It is important to be aware of all of the applicable standards and regulations when performing electrical work. Electrical work can be dangerous, so it is important to take the necessary precautions to protect yourself and others. This includes wearing appropriate personal protective equipment, such as gloves and safety glasses. It is also important to de-energize circuits before working on them and to use proper testing equipment to verify that the circuits are indeed de-energized. If you are not qualified to perform electrical work, it is important to hire a qualified electrician. Electrical work is a complex field, and it is important to have the knowledge and skills necessary to perform the work safely and correctly. A qualified electrician has the training and the experience to perform electrical work safely and correctly. They can also ensure that the work complies with all applicable codes and regulations. Learning the NEC can be a challenging but rewarding experience. It provides a solid foundation for understanding electrical principles and practices. With dedication and hard work, you can master the NEC and become a skilled and knowledgeable electrician.